This video covers division rules of exponents. So the only operation we're going to be using is division in our exponents. And there are more videos on the rules of exponents if you will look on the website. Okay, so again, exponents are numbers written above the variable or number. And so if we have 3x squared, the 3 is the coefficient. That just means it's the number in front of. It has its own exponent of 1 because when a number or a letter is written without an exponent, it's understood to be 1. And so it's not part of the exponent here. Now this x squared, the x is my base. It's what is being multiplied. And the exponent tells me how many times to multiply it by itself. So my 2 would be my exponent. So the exponent tells you how many factors of the base that you need to multiply together. So if I'm looking at x squared, it just means I'm going to multiply x times x times itself. And then if I have 6 into the 5th, that 6 is not part of the exponent because it's not in a parentheses, it's not included or anything. And so it's just going to be in front. And then I have 5 n's times n, times n, times n, so forth, 5 times. And so that's what exponents, or the definition of exponents. The division rule states that if you have a to the m over a to the n, if the numerator contains the larger exponent, so if m is greater than n, and then on this one, the rule says a to the m over a to the n is 1 over a to the n minus m if the denominator contains the larger exponent. And what this means is if you're dividing numbers with the same bases that have exponents, you're going to subtract the exponent, but you're always going to work from the larger exponent. And so the only catch is you need to look at the location. Now, numbers have two locations that they can be in. And that is, they can be in the numerator on top, or they can be in the denominator on the bottom. And those are the two places they can be. And so if you will always work with the largest exponent, you won't end up with a negative exponent as you're working through the problem. Because if you do end up with a negative exponent, you have to apply another rule to the problem to simplify it all the way. And so most problems require positive exponent answers. Okay, so let's look at how this works. The rule states subtract the exponents, work with the larger exponent. So let's look at this problem. We have a to the 5th divided by a to the 3rd. Which one is my larger exponent? Well, hopefully you understand that 5 is bigger than 3. And so we're going to be working on the top. And so we're going to write our a. And then we're going to subtract 5 minus 3. And right now I'm writing that step. Eventually you'll get to the point where you don't have to write that step. But 5 minus 3 is just 2. So we get a squared as our simplified answer. And a squared is much easier to work with than a to the 5th divided by a to the 3rd. Okay. Hit the right button. All right. X squared divided by x to the 6th. Okay. And so this time, the 6 is the larger number. And so I'm going to put my x on the bottom because it's where there's more of them. And I'm going to take out 2 of them. So I have 6 minus 2. And because you have to have a placeholder in the numerator, it's always 1 because we've divided out numbers. And so we end up with 1 divided by x to the 4th because 6 minus 2 is 4. All right, I'm going to put these up together. Okay, So the reason I put these up together is so you can see the similarities between the problems as we work. All right, so on number 3 here, we have a to the 5th, b to the 11th, c to the 2nd, a to the 3rd, b to the 3rd, c to the 2nd. Okay, so we have to deal with like bases. Just like with combining like terms, you have to deal with like families. You can only combine the same letters. And so the first thing I see is this c squared. If c2 is on the top and the bottom, it can cancel to be 1. And so I'm going to put my equals and I'm going to set my fraction bar because I need to know location, numerator or denominator. So looking at the a, I have 5 is larger, so it's going to stay up top. And 11 is larger, so it's also going to stay up top. So I'm not going to have anything in the denominator. And so a and 5 minus 3 is 2. And b, 11 minus 3 is 8. And if you put the 1 on the bottom, it's not going to change anything. So then you can rewrite it as a squared b to the 8th. And it's, again, not necessary to have the 1 on the denominator. It's mandatory to have it in the numerator if nothing is written there. Okay. So again, let's look at this one. Now, they're out of order. It's got the y first, then the x. So you have to be careful and look at the details. And so I've got to deal with either one. It doesn't matter to me which order you deal with them in, and decide where they need to go. So the y squared, and let me just highlight it so you can see what I'm talking about. The y squared and the y to the 7th are not lined up, okay? And that's okay. Sometimes they're not going to be lined up in the problem. And so I know that 7 is larger, so the y is going to go on the bottom. And it doesn't matter if you put it first or second. I always like to write my answers in alphabetical order or in order by their exponents, largest to smallest. So I put the y second here. It doesn't matter. So 7 minus 2 is 5. So now I've got to decide on the x's. And so I have x to the 9th and x to the 12th. So my 12 means that the x is bigger on the bottom, and 12 minus 9 is 3. And so now I have to have the placeholder up top. Well, if everything cancels, it just means that there is 1 left at the top, just the number 1. So it's 1 divided by x third, y to the 5th. Now, this one is not necessary because I can actually do this operation. I can divide those a squared b to the 8th by 1 and get a squared b to the 8th. I can't divide 1 by those values because I don't know what x is or y is. And so that problem must stay like that. It is not the same answer as this one. And there's a difference in the numerator and the denominator ones. So keep that in mind as you're working through problems. Okay, so now we have a doozy here. And so I'm going to just separate them out and figure out where they need to go. Our x is, that's the only x, so it's bigger on the bottom. And so 13 minus 8 is 5. I'm going to highlight them so you can see what I'm doing. 13 minus 8 is 5. And so I have x to the 5th here. Okay. Then I'm looking at the y's. So I have y squared over y to the 33rd. And so let's put the y's here. Why did I put it on the bottom? Because 33 is bigger than 2. So 33 minus 2 is 31. And now I have a c to the 6th. I don't have another c to the 6th. So I'm just going to write it on top. That's where it's at. C to the 6th. And then I have this z to the 12th on the bottom, and so I'm just going to record it on the bottom as well. Z to the 12th, because it doesn't change. And so if there's no numbers or no letters there for you to worry about, you're not changing them at all. And so this problem here becomes c to the 6th divided by x to the 5th times y to the 31st times z to the 12th in the denominator. All right. This one, again, it looks like we have things out of order. But now I have a c without anything. What does that mean? Okay, so I have to deal with an exponent that's not written. Okay, the number that will not change an exponent is 1, because c, just c, means there's just one of them. And remember, the exponent is how many factors there are. And so there is 1c here and 1c here. And if they're the same, you can just cancel them out. And so now I just have to look at the a, the b, and the d. And so a to the 5th divided by a to the 4th, you subtract your exponent. 5 minus 4 is 1. 5 is larger, so it stays up top. And I can put the 1 there, or I don't have to. It doesn't matter. Okay? B to the 11th and b to the 11th. Same. It divides out to be 1. And then d is by itself, so it just comes up here, and you don't have to put the 1 on the bottom. All right. So far, so good. All right. I have other videos on rules of exponents. This video just dealt with problems for division. So my other videos are negative exponents, power rules of exponents, zero rule of exponent, and multiplication of exponents. Check them out on the website, and thanks for watching.